So we're now looking at the flight service, and the flight service, as you might imagine, is what implements the methods that are exposed by the flight controller. And keep in mind, we're still focusing on the front end app gateway or API gateway entry point that a remote client like a browser, like Android app would access. And as we talked about with the controller, everything that's done here is using Project Reactor reactive types to asynchronously perform all the operations that are defined in the controller. And the main difference here is that now we're really into the implementation details, whereas before we were really looking more at the API that's exposed back to the client. The flight service is annotated to be a service, which enables auto detection and auto wiring of everything that depends on the various pieces that are defined here, using class path scanning to find the mapping. And then there's also another thing here that's a discovery client. We'll take a closer look at that. And that's used in order to have this app gateway automatically redirect calls to the appropriate microservices. And those microservices can then be defined and essentially deployed to run in processes that are going to work on other computers in the cluster or in a cluster of computers. So everything is no longer running in the same address space as it was when we took a look earlier at the flight's monolithic case study. Now, we had looked earlier at the microservices-based approach that used Spring, Web, MVC, and functional programming. And now we're taking a look at the one that uses WebFlux and also uses the reactive programming. So if you take a look at the fields in flight service, you can see we have a discovery client, which is auto-wired. That'll get connected up. And then we also have another another field that's called web client, and that also gets auto-wired as well. And you can see down here, we have a bean that's defined that knows how to make a web client. And we've got various things that make that easier to automate using the various approaches for dependency injection that are supported with Spring. So the main difference, by the way, just a quick recap between web client and REST template is that REST template is intended for use with web, with the Spring, Web MVC, synchronous two-way calls, whereas web client is intended for use with the asynchronous approaches using reactive types. So we'll be using that in this implementation. We have another field called base URL that's just used to help support mocking when we do testing. All right, so let's start taking a look at the methods. These are the things that actually do the work. This is really the interesting part from getting things to work reactively. And you can see that get airports has an implementation that makes a call to a make get request flux helper method in the utils class. And you can see it passes in the web client, which is up here, been dependency injected and auto wired. We have a call to a helper method called make airports URL. We're going to take a look at that in a second. And then we also pass in the type that we want this to return. So we want the make get request flux to return a flux of airport objects. And this is how we're going to do that. But before we take a look at the make get request flux method, let's take a look at make airports URL. So all this does is it takes the base URL and it goes ahead and it concatenates the airport, followed by the slash, followed by the airport's endpoint. So that means this is going to call out to the airport's microservice. And we'll see how that all gets done here in just a moment. So the secret sauce here is done in this little helper method called make get request flux. And I wrote this so I wouldn't have to keep typing this code laboriously over and over again. This is the way you make an asynchronous request using web client with Spring WebFlux. So what we do is we make this a generic method parameterized by type T, which is the return type. In this case, it's going to be airport. That's what we want to use. That's what we parameterize with, but this is generic, so we don't really care about that. So we say, hey, web client, go ahead and create an HTTP GET request, please. There's going to be a GET request as opposed to, say, a POST request or some other kind of HTTP RESTful type. Build a GET request to, in this case, make a request for whatever the URL is. In this particular example, it's for the airports, but it could be something else, as we'll see later. And then we go ahead and say, retrieve the response from that microservice. So that's actually where the call is ultimately going to be triggered from. And of course, this all works reactively. So it has to wait for a subscribe to get called before anything happens. But so it's kind of lazy. But the point is that at some point when this call chain gets invoked, this fluent chain of method calls gets invoked, that will go out and make the call to the microservice. And what we'll get back here will be a body to a flux of the parameterized type. So in this case, that's going to be a type T, which for this particular example, as we saw earlier, is going to be airport.class. So that's just, again, just a little helper method, and you're going to get back a flux of type T, which in this case, as you can see, is a flux of airports. And that's precisely what gets returned from the get airports method. And what's cool about all this is all done asynchronously, triggered from the client side, if you have asynchronous clients. And that way, the whole thing runs asynchronously on the client. The whole thing is going to run asynchronously on the server. Now, if you are running on Android, which doesn't really have full end-to-end support for asynchronous clients, the server side will still run asynchronously, but the client side will not be quite as asynchronous as we might want. It's close to it, but not perfect. Hopefully, they'll fix that with some later version of Android. We'll take a look at how you could do that later. Here's the find departure dates method done also asynchronously. How this works is we're going to call a helper method called get airline services. And get airline services goes out and gets a list of all the Eureka registered microservices that we have. And it's going to take that, which is going to come back as essentially a list. And it's going to use the from iterable factory method that's part of the flux class to convert that into a flux. So now we have a flux. And then we're going to use the filter method on a flux to only emit the names of microservices that contain the substring airline. So we're going to have things like Southwest Airline, American Airline, United Airline, blah, blah, blah. And so only those will be included in the flux that gets returned back. So we have essentially now we have a flux of these strings that correspond to airline related microservices. And then we're going to use a really powerful operator that's part of Project Reactor. It's also part of RxJava for that matter, called FLApp. And what FLApp is going to do here is for each of the airlines that we've got, it's going to go ahead and in parallel call find airline departure dates, passing in the departure airport, the arrival airport, and the airline. So find airline departure dates, take a look at that. Keep in mind that all these things are going to take place in parallel, which is exactly what you want. You want our app gateway to take a request for a client and then make parallel calls to all the microservices running in the back end that will provide each airline's responses to that request, because each airline is going to run in its own microservice. So what we get back here, or what we're going to do is we're going to take these parameters. We're going to call the make get request flux method again, just like we did before, except this time we're going to make an airline URL instead of an airport's URL. And let's go ahead and take a look at what that does. You can see what that does is it takes the name of the microservice, takes the endpoint method. There's a couple different things. There's flights, there's best price flights. We have the departure airport. We have the arrival airport. If we have a departure date, we also include that in the URL that we're constructing. And this URL, notice this URL doesn't say where that microservice runs. It just has the name of the microservice. It says like SWA-airline or AA-airline or United-airline or whatever. And it leaves it up to the Eureka discovery service to actually figure out where that particular microservice is running. And that's one of the cool things that's baked into WebFlux and for that matter, into Spring WebMVC. So we get back this URL, which comes back as essentially a string. And then we go ahead and make that request, the get request flux thing, which builds up a get request, a URL, retrieves it, and then converts it to what we want as a result, which in this case is going to be a flux of local date objects, because that's what we want find airline departure dates to give us back. That's find departure dates. Now let's go ahead and take a look at the really interesting methods. Not that these other ones weren't interesting, but these are the really interesting methods. And these methods are find flights and find best price flights. And as you'll see, they both do the same thing. They both call to a shared internal method called find flights impl. See, there are two different calls here. Everything's the same except the operation. So find flights will pass in the flights constant to find flights impl, whereas the find best price flights will pass in the best price flights constant to find flights impl. And then something a little different happens for find best price flights. And we'll come back and look at that in a second. What it's to give you a little overview of coming attractions, a preview of coming attractions. It's going to go ahead and only return the cheapest priced flights. There could be multiple ones that match that. It's just going to return the ones that have the lowest price. We'll come back and look at that. But let's first look at find flights impl. And we'll imagine, for sake of argument, we're just going to go ahead and find all the flights that match the departure airport, arrival airport, and departure date. So here is find flights impl. This is a really, really cool. And this shows the power of reactive programming quite dramatically. So what we're going to do is we're going to create ourselves two local variables. The first one is a mono, and the second one is a flux. And the mono, called rates, will be a mono to a map that maps strings to doubles. And the strings will be the name of the currency, like dollars or pounds or Swiss francs or whatever, and then whatever the exchange rate happens to be. And that computation, which we're going to look at in a second, is going to run in parallel with another computation that's going to go ahead and get a flux that contains all of the flights that match the departure airport, the arrival airport, and the departure date. So both of those things are going to go on in parallel, which is exactly what you want. You want to find the current exchange rate. You want to find the list of flights. And then after we've found that, we're then going to join those things back together again. So you can kind of think of this almost like a sort of a fork join-like model, where we're going to fork off some tasks to run in parallel. One task will find the exchange rates. Another task will find the flights. And then after we've found both those things, then we'll join them back together again and figure out how to update the prices of the flights we found with the appropriate currency that we want it converted into. So that's kind of the high level view of this. So what we're going to do is we're first going to call a helper method called getRates. So let's go look at getRates. What getRates does is it's going to turn around and make a call using the discovery services of Eureka to asynchronously find out what the exchange rates are for a given currency. And you can see here, like for dollars, we'll get back a flux of all the exchange rates for pounds, yen, RMB, euros, whatever else we're interested in here supported. And the way we do that is we make a call to this little helper method called make exchange rate URL. And that just indicates we're going to go ahead and make a call to the exchange microservice. And we're going to make a call to the rates method of the exchange microservice. And we're going to indicate what the currency is that we want it to convert it into. So that's how we get back that. And that comes back as a flux of exchange rates. And then what we do is we take that flux of exchange rates, one that comes back, and then we create a map. And the map is going to have the from currency, which would be, again, like pounds, dollars, yen, and whatnot. And the values will be the rates for each of those currencies. So for each currency, we're going to have the exchange rate. So we get a little map back that gives the current price of that. That computation all takes place asynchronously, goes out asynchronously, requests the results from the exchange rate microservice, and that runs in parallel with the next set of things we're going to do. And the next set of things we're going to do is we're going to go find all the airline services, which is kind of what we've done before. So we'll get back American Airlines and United Airlines and Southwest Airlines and so on. And then again, we're going to use the flat map concurrency idiom. For every airline, we're going to go ahead and find the flights that match. And if you take a look at find airplane flights, that's going to go ahead and make a request to the flights microservice and to a particular flights microservice. Again, American Airlines, Southwest Airlines, and so on. And for this, we're going to go ahead and make the airline URL. We looked at this before. This just creates the URL for a given airline. And what we want this to come back with is a flight object, and it'll actually come back as a flux of flight objects. So what we have now is we've got ourselves a flux of flights and a mono of rates, and all that stuff is often running concurrently in parallel. And then we call another helper method called try to convert currency, or try to convert currency. And that takes in the rates map, it takes in the flights, and it takes the currency we want things converted into. And this is, again, very, very cool. So what we do here is we say, hey, rates map, which is this mono, when your computation is done, call this method, call this operator called flat map many. And what that basically does, as we'll see in a second, is it's going to take the map that's emitted once we've got the exchange rates, and then for each of the flights in the flights flux, we're going to go ahead and find out what the currency is of that particular flight. So is it in dollars? Is it in pounds? Is it in Swiss francs? Is it in renminbi, yen, euros, whatever? And if it turns out that the currency is already in the right format, then we just return the flight. We're done. But if the currency is not in the right format, then we take the current price of the flight and we multiply it by the currency in the map. We go and look up the rate. We multiply it by its exchange rate and update the flight's price. So what we get back from this is we get a flux that essentially has either no changes whatsoever if it was already in the right currency, or everything has been properly updated to correspond to the conversion factor that we need. And this, again, is this magic ability to kind of combine together the results of two asynchronous computations, one of which was a mono and will yield a single result or emit a single result, which is the map. The other, which is a flux, which will emit essentially a stream, if you will, of results. And once we do all this stuff, then we're going to return this as a flux of flight objects that have matched the departure airport and the departure date and the arrival airport and have been properly converted. And all those things will come back. So we'll get back all the flights that match, and they aren't really sorted in any particular way. They're just whatever came back from the results that were provided by the various microservices. Okay, the last thing I'm going to take a look at, because it's also super cool, is this other method called find best price flights. And what this does is it starts out by doing the same thing that the find flights method does. It goes and finds all the flights that match the departure airport, the departure date, the arrival airport, and so on. But then it does something else. We get back essentially a flux of these flights that have now been converted, and then we collect them using the collect terminal operator, using a collector we wrote called cheapest price collector. And this is just the coolest thing ever. So here is the cheapest price collector class. It's a collector. So this is just good old modern Java, Java 8 and beyond collector, custom collector, which is going to take essentially a flux of flights or a stream of flights. It's going to store them in a list of flights internally, and it's going to return a flux of flights as the results of the finisher method. And the way it works is super clever. We have a little local variable. It's going to keep track of the minimum value that the collector's seen so far in its flux. We have a supplier factor method that returns a new array list. That's how it's going to be stored, as the so-called mutable result container. We have an accumulator, and this is where all the magic happens, is in the accumulator. So what happens is for each element that we see in our flux, we check to see if the price of that particular flight is less than the minimum that we're keeping track of here as a field. And if it is, then we're going to clear out the array list of lowest prices because we found one that's lower. So we're going to clear out that list. And then we add that trip response into the list. And then we make that price the new minimum. So whenever we find something that's the cheapest, we update the particular result. If the results are equal, however, if the trip response's price is equal to the minimum, we go ahead and add the trip response to the lowest prices list. So what we're going to end up with at the end of all this is a list of lowest prices, all of which match the lowest price. There's a combiner, which we would use if this was used with parallel streams. We're not using it with parallel streams, but if we were using it in a parallel-like manner, this would concatenate two lists together. We don't use that. Here's the finisher. This is the one that is going to convert the list of flight objects into a flux of flight objects. And you can see all we do here is we just use the from iterable factor method as a method reference, and that will be used by the Java type system to automatically convert the list of flights into a flux stream of flights. And then down here, we have the collector characteristics, which we just don't care about. We don't need anything. And then here's the toFlux factor method that makes ourselves a cheapest price collector. So super duper cool, very, very powerful capability here. And we use this in order to basically take the results of all the things that matched and then just find the cheapest ones. And what we get back from collect in a reactive model for Project Reactor is a mono to a flux of flights. But we don't want a mono, we want a flux of flights. So we use this method called FLAP which will essentially unwrap the mono and return what it points to or what it contains, probably a better word than points to. And in this case, that's going to be the flux of flights. So that's how we convert the mono to a flux of flights into a flux of flights. And that's a good little idiom to know about where you pass in function identity and it just goes ahead and kind of unwraps the mono. So that's essentially all the methods that we have in the flight service. As you can see, there's a lot of methods here, but they're organized in a very consistent way, and they allow us to have completely asynchronous app gateway functionality. So all those microservices that we're accessing in the back end are all going to be accessed asynchronously from this front end app gateway.